Hello, hello, good morning, and happy Wednesday, halfway through the week. And today we are continuing our playing of Shenzhen I, outsourcing ourselves for electrical engineering. Drone activity is heavy, yes. That is very true. Also, hello, stacking. Yeah, you know what? So far, I think I've seen it always be heavy with drone activity. I don't think I've seen... Well, maybe... Was it medium last time? I don't remember anymore. I'm guessing it's like random what it chooses to have. Okay, but last week, we got ourselves to... Oh, we fixed up, let's see, the game console because this person wanted something for right, like a little what is it, the controller module. Ooh, and Zilby's here, which means I can add in cat. So we're putting him right now for here, but I don't know if that's the best place for him continuing on. Anyways, let's see. Did we do the... I think we looked through this one. Right, it's an AI companion, which we're gonna have soon enough in a real world. If not already. I think that there's people and companies trying to create those already. Okay. Tag. You're it. Product. Laser tag equipment. Create a working design for this product to view histograms and leaderboards. All right, I don't need to read that out every time. I need to remember that. Okay, Carl's given us this one. You don't like Carl, right, Stacking? Hi, Zilby. You wanna come over here? Are you in exploratory mode? He's the guy we all know and have to love. I love that it's the have to love, or at least, you know, pretend to love. Sylvie, what's up? What do you want? Do you want to come over here? No? Now you're gonna make your trek back across the desk? Okay, I think he's going back. Please don't blame me for this. Okay, never start an email with that. That's not a good way to start the email. I have a friend, more like an acquaintance really, from a while back, many jobs ago. He's always been a bit of a nutter. And I guess what happened was he made a decent bit of cash with an app or something and decided to retire from the programmer's life and build laser tag arenas for the rest of his days. That's not the worst. Why is that bad? That's not the worst of it. He's calling his franchise to be the Awesomeplex. Capital's his. Okay. In any case, he wanted to see if we could make some score-keeping wearables for it, and I said yes. I'm not entirely sure why. I suppose in the unlikely event his arenas do take off, it'll look brilliant in hindsight. He's the old guy in a company that has somehow managed to work at the company for 40 plus years, and he's the only one that knows how the one function works. Yeah, no, I mean, that's like the Solaris dev. The Solaris sysadmin. Okay. Why is he just shitting all over his friend? And they're like, them trying to like make their own business. Awesomeplex, when it's done, we should try a match in the office. Laser tag looks like so much fun. I mean, how about we go to their, okay, never mind. A lot of simple inputs, either on or off. Too many for a microcontroller on its own, but a good use for the DX300. Okay. Okay, so we have ammo, we have a lot of things here. So we have hit, respawn, alive, trigger, reload, fire, a huge board, finally, which may or may not be a good sign. Okay, hit is a simple input connected to an array of laser sensors on a vest. So this will tell us if we've been hit. Respawn is a simple input connected to a quick connect jack on a vest. Okay. Alive is a simple output. Okay, so input, input, output. Connected to an array of LED lights on a vest. Okay, so we just want to know if we're alive or if we've been hit. So probably like if we've been hit. Oh, okay, so like we've been hit, we are currently dead. So we need to track the state. We are dead. Then when we respawn, we're back alive again. And then when we're alive, we want this to be on. Otherwise, we want it to be off. That seems simple enough. Trigger and reload are simple inputs connected to switches in a replica gun. So it's a laser gun. Hi, what's up? Okay. Fire is a simple output connected to a laser and effects module in a replica gun. Okay. When a player is hit, their vest should be set to not alive. So false. When a player is respawned, their vest should be set to alive. When a player reloads their gun, whether alive or not, their ammo count should be set to the ammo reload value. Okay, so this is the ammo that they have. And then if they reload, we set, okay, so we need two states here. So we need two of these essentially to hold state. When a player is alive and pulls the trigger, the gun has ammo remaining, the gun should be fired, and the ammo count should be decremented by 1. To allow for realistic operation of various replica guns, the ammo reload value is set by the operator using a dial that can be read as an X-bus input. You only get 5 shots. You better be the Clint Eastwood of laser tag. I know. I have played laser tag like a couple times in the past, and I don't remember ever having like an ammo where you need to reload. The way I remember it is that you just have the a cooldown after you fire, so you have like unlimited shots, but you like it takes like, you know, you can only shoot like once a second or something like that. This is going to be like a much more like, yeah, it's like 5 shots is a very interesting one. This must be for testing purposes. To make it easier for QA to like, okay, did we run out of ammo? That kind of thing. I've been to one where they had a reload station in the middle and holding your gun to it was the only way to reload. Oh, interesting. Okay. Yeah, mine definitely did not have anything like that. Oh, okay. You're done, Zilby? All right, so now they recommended, hey, we got everything here. This is good. They recommend, oh, okay, we don't have everything here. The DX300, so they recommend this. This is the first time they've called it out to recommend. But I also believe we're gonna need these twice because that data is gonna be pretty big. You also, at that one guy that just camped the station, yeah, that is a problem, is like, whenever you have like Call of Duty or games like it, you always have the people that are camping. It gets so much worse when it's in a real life situation. Okay, so we know we need these things. We have our ammo. Okay, so we have hit, respawn, and alive. So this feels like it's its own thing over here and completely separate from over here. So I can basically, what are you? You're gonna be like a P, right? So I can put you in there, and I can put you in there. Oh, but then I need an output for a live too. Yeah, so I think we're gonna need 2 of these. Because these are P's, so I can reverse you and just throw you like this. This is an X. So what if I throw in an X like that? And then we're going, yeah, so what if I do something like this? And so we'll see if we can get the hit respawn alive working. So I guess, what should we be at the beginning? Should we always start alive? I'm thinking 1 0, 1 alive, 0 dead. I'm pretty sure that we start alive. So let's move 1 to dat. Let's have a label for starting here. Now we're gonna get out of here, and if I remember correctly, we're gonna be able to see like 0 1 1 or something like that. I kind of want to move X0 to ACC. I just want to play around with this. Let's see, so the first one we got... Wait. Do we start dead? Oh, we start dead. Oh, okay. That's good to know. We start dead. And then, yeah, okay, so we got 100 because, right, this is 100, this is 10, and this is 1. That changes things. Okay, so we start dead, so we already have a 0 in here, which is great. So at the very end, we want to send the status out to here. So what if we just move dat to P0? We're going to sleep 1. Now right here, we get a respawn. And at the same moment, so it's not, there's no lag we want. As soon as we get that, we turn alive. So I want to read this in. So move X0 to ACC. And I want to check to see if that is 100. So I want the third one. I don't think it's the digit. There's the one where it lets you look at the digits in a number, or the positions in a number. Yeah, okay, so isolate the specified digit of the value. Okay, so isolate the specified digit of the value in the ACC register and store the result in the ACC register, so we lose it. Set the digit of ACC specified by the first operand to the value of the second operand. Oh, so that's so basically get or set. So okay, I want to get. So we're gonna lose ACC with this, which right away won't be a problem. So if I RI, so get 0 gets me 6. Okay, so I want 2 for the 5. So give me 2. And then I want to get target equal to ACC 1. Oh. EQ. Okay, so if you're equal to 1, then that means respawn has happened, and therefore we're alive now. So that way I want to move 100 to that. Otherwise, nothing happens like that. Now, we haven't slept yet, which means I wonder if I can still remove this. So then can I move ACC to 1 again? No, move ACC, move exert to ACC again. And otherwise we could use like memory, because they give us this memory. Yeah, we have random access memory and we have a stack. I could see using both of those. Move 0 ACC. So now I want to check to see if we've been hit. So test equal, oh no, we want to get 1. Test equal ACC 1. Okay, so now if we've been hit, I want to move 0 to that. And at the end, we move that out to here, and then we're gonna start again. I want to see if that makes these all work, the top 3. Okay, we are good to go. I guess they want to start dead to get everyone in arena without that one guy. Oh yeah, that probably makes sense. Although this is like 5 ticks, right? I get no. It's just what the signals are sending to us. Yeah, it would be hilarious if they just start all alive and just like one person goes boom, 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 boom. Okay, you're all dead. It's also why you have ammo, right? You can only kill 5 people. Okay, so half of it's done. It's probably the easiest half. Let's see, I might want to store that over there for space. Now we have trigger, reload, and fire. So fire is going to be an output. Trigger and reload are inputs. Oh, interesting. Okay, so we're going to see that. So I think we're going to need this again. And so we're going to throw in U. I guess this doesn't really... I mean, I could throw you up there just to be easier. But it won't really matter. The output's going to be the same anyways. Now you are an X. Okay, so you're an X, so I could throw you in here. And then you. Sure, why not? That's gonna bother so many people. Okay, so if we have this, we want to test to see now it looks to me like this one we actually start with the full ammo. So if we initialize, now what's the next thing that happens? We pull the trigger, and trigger is gonna be 1. So if we move X2 to ACC, get digit 1, test equal ACC to 1. So if we fired, I want to now I need to move that to ACC. This actually, we're gonna run out of room here, I bet. Sub 1, move ACC that. That's, yeah, this is gonna be rough. Okay, so that's if we fired. If we've reloaded, so then we need to, oh, this is also, we have to move X2 to ACC. Okay, so if you've done the thing, so if we've reloaded, we want to move X0 to that. And I guess that's it, right? No. That's not it. When we fire, we also want to... okay, so when we fire, we need to make sure that we actually have the bullets for this. Here, we can just do this right here. Let's jump to start. Everything will be fine up until we run out of ammo. So if we try to fire, like here, I think we fire too many times, and we're only allowed to fire 5 times. Hi, so do you want to hang out again? Or just hang out down there? Oh, and then I do need to sleep. Do I sleep and then jump to start? I think I sleep 1 and then jump to start. Our DAT is negative 12. That's cool. But we do have access to you. So we have you and we have you. I wonder which one we want to use. Oh, you're set. Okay, I can set these things. Whereas you're access memory, so I don't want that. I probably just want this. Is this a stack? This is a 100p 14. Random access memory. With its convenient auto increment feature, you won't have to waste precious registers keeping track of memory addresses. Okay. All memory cells initialize to a value of 0. All memory pointers initialize to point at the first memory cell. Memory pointers can be read and written over XBus with the A0 and A1 address pins. Memory values referenced by pointers can be read and written over XBus with the D. Okay. Oh, so I have to have two things. So A0 and A1 for write. So write and then read. After reading from or writing to a data pin, the corresponding memory pointer will automatically increment to the next memory location. Following example circuit reads into 3 value packets from input and writes them back out to output in reverse order. Okay, so move 0 to X3. Okay, so move so store 0 here. Move 0 to okay, so move whatever the input is. To X2. Why is it? Okay, this is, I'm confused with this. This is an image, isn't it? I can't like select. I can select this stuff. I can't select these. Full Stack Live, hello, how are you doing today? That's not a game, can it be? Yes, this is a game. This is a game called Shenzhen I, and it's a game where we program in assembly and solve electrical engineering problems to proceed to forward the plot. And so we're currently trying to build a system to like for a laser gun vest. All right, let's reset all of you. I just want to play with you because that example didn't really help me at all. Okay, so we have D1 and A1. So if we look at you, you start with moving. Okay, so you move 0 to the A0, to the A. And your A is down here. So if I start with move 0 to X1. And I just want to step. Huh, so, okay. But then you start moving things to the D. So then let's say, we move like, I don't know, 5 to X0. Move 1 to X0. Move 100 to X0. So if I do that, oh, the 0 does literally do nothing. Oh, and it overwrites it. Is that right? Wishlisted, amazing. That's like Exapunk squared. Isn't this this is made by Zachtronics, which is the same company that made Exapunk, right? Okay, so what if I move, So this is what? 1, 2, 3, 4, 5, 6, 7. So move, let's create a counter. Let's just, I don't know. Move ACC to X0, add 1, sleep 1, and then just keep on going. What do you get there? Yes. Oh, it auto overrides it. Well, that's okay. What they're doing is moving the right pointer. Then to read it, you need to move the read pointer. Yeah. That makes sense. Okay, so if I do that, add 1, and then if I want to do the exact same thing, we can move A1 to DAT, let's say. Sorry, move X1 to DAT. Well, I see DAT going. It's not. Is that not moving the read pointer? Huh, so I can't actually see the, okay. So that's not the read pointer. That's like this side. So these are both right pointers. If I like threw something in here on this side, it would write in. That's my guess. So like if I threw you in there and like right before this, let's move that to X2. Yeah, so you get weird things when both of them are trying to add at the same time. This one wins. Okay. Good good to know. But I think we can still use this. Right? Can I? Oh, because I can't move the read pointer back down. So can I actually use this properly? I basically just need another state, don't I? Okay, so if I do something like this, now we have to start with the full amount of ammo. Can I sub? Can I do something interesting? Can I can't tell this to subtract, right? This is chosen by the screw. So this is always going to be 5. So I do need to do that start thing and move it to data unless I'm almost feeling like I just use this thing. And store the number of shots that we have. I don't know if I want to like move this over here. I don't know if I want the small one. Maybe I want the bigger one. I don't have to reload right away. What if I want to do something like this? Can I, if I reload, move X0, oh, I could send it to X1. Or I could send you back to that. Or we could try that. So that reloads. I don't know if I want to jump anywhere. When we get the trigger, so I have to, okay, so we have to figure out what we're gonna do and move into here. So I have to move X3, the ACC. Let's handle trigger first. So let's get 1. If we test equal to 1, we have known that we've pulled the trigger. Maybe, oh, I should do the other one first. Let's get 2. Okay, so if you're equal to 1, we've pulled the trigger. I want to move, we want to jump, reload. We want to move X3, ACC, get 1. Test equal to ACC 1. So in this case, we're pulling the trigger. So we want to, I'm basically not using this at all right now. I'm not using that. So if I move date ACC, sub 1, test greater than ACC 0. So if ACC is greater than 0, then I can we can fire, right? So then I want to move move 100 to P0. And are we done with that? We fired for one thing. Oh, sleep 1. And then I want to go to basically just so let's run, move, then I want to run. Jump to run. That can't work, right? No. Oh, fire is a one thing. One thing. I need to move 100 P0 and then I need to immediately move 0 to P0. I need to sleep and then move. Okay, so ooh, what if I then just do this? And all I'm doing here is tell you to fire. Does that send it out 100%? This part is the one that takes the most space, is like figuring out which one of these hit. I could also then outsource essentially and like say, hey, you go do this thing, and like have one of these or one of these do that. I could also have 2 of these. If I don't care about wasting money, which I don't really care about wasting money, I could do something like this, right? No, because I need to keep track of the ammo together. That won't work. But you know what else I could do? We could, because we know that this one never has anything, I could not do, okay, so we move X3 to ACC and I don't need to isolate the digits. What if I just don't do that? We have 3 states, and so that could be in, can I ever reload at the same, am I ever reloading at the same time that I'm firing? No, at least not in this first test set. So what if I just cheat, like any good developer does, and we create an edge case, in which case you can't fire and reload at the same time. Who would ever do that? Okay, so if we test equal ACC, and then this would be 100. So if I do 100 like that, so you're only reloading, you're not firing at the same time, then jump to reload. And then do this, then it keeps on running again, right? Wait, is this gonna be an infinite loop? Because I need to sleep. Yeah, I think that's an infinite loop. So I kind of want to move X0 to dat to start it off with. Then we have run to go here. Move X0 to dat again to reset. Move then we continue on. I don't need to move you to ACC again because we still have you. I don't need to isolate the digit. And now we check to see if it's 10 in there. If you're 10, you're firing. I do need to move that to ACC. Sub 1. Test to see if we're greater than 0. How about this? Sub 1. Oh, and you need to be like this. Move ACC to that again to store it here. Test greater than ACC, so I want really stat. If you're greater than 0, but this is still firing. Okay, so if you're greater than 0, move 100 to P0, sleep 1, move 0 to P0. Otherwise, minus sleep 1, jump to run again. Why am I firing right away? Oh, because I... Wait. Oh, I misread it. We don't start with any... Oh, we don't start with this. Okay, cool. I don't need a jump run. We're just done. I misread the test input. We start with 0 bullets. Or laser bullets. Okay, well, I mean, we've made a very peaceful weapon. You can't fire at all ever. That's good, right? That's like the point, I think. Okay, what happened here? Okay, so we're gonna move X3 to that. We have 10 in there. We've tried to fire 3 times. Oh, wait. Reload. Why? Oh, data is still 3. Okay, hold on. That's where we really need to be. Okay, so, oh, it's 1? Is that 110-1? Oh, well, okay, so I just... If you're 1, you're reloading. Okay, so we fired the first time, so 1... so trigger, 1, 2, 3, 4... And then the 5th one, oh, because equal to 0. Okay, so it's not greater than dat, -1. Okay, so we fired 1, 2, 3, 4, 5 times, and then we try to fire a 6th time. That correctly failed, and then we reloaded. And then we tried to fire and that didn't work, but then it started working again? Okay, what happens here? So we are currently in the state. We have 5 bullets. I noticed it got to a -2, so when I loaded it was only at 3, which is weird because I'm trying to move ammo in here and not add 5, that's odd. I'm confused about that. Okay, so here, I'm at DAT 5. And so you should fire when I... No, you should not fire. Wait, why? We reloaded, and I pulled the trigger. Wait, why aren't we supposed to fire? Yeah, I have us as fire. After a reload. I'm confused. Oh. Oh, we're dead. Do we... Oh, yeah, you're right. Look at that. Okay, so if we're dead... Oh, we can't fire when dead. Very good point. Very good point. Okay. Well, that kind of sucks. What? I mean, it sucks for me because I'm developing this. It's, you know, kind of makes sense from a like logic point of view. Fine, okay. We need that. We need a that guy clause in that one too. Yeah, that's true. That's true. It's like, okay, come on, just be... be good here. Okay, so right, what do we want to do? We want to, now we know if we know if we're dead here because we have this in dat, and I could send dat over here and we can read that, and I have 2 more lines, and this might work. So I have an X. I could throw you in here, and then we can just also say, actually, you know what? This is where I think this might come in. These are all X's, right? This is a read. So if I'm reading out of here and I'm writing from here, this might work. So when we're killed, we're alive. I want to, okay, so move 0 to dat, move dat to P0, and I also want to move dat to X3. So I'm storing in. So here, if we, yeah, okay, so now we're storing our alive status in here. And then I want to read our alive status out here. So when we're firing, so when we do, before we even do this, I should check to see test equal x1 100. If you're not alive, I want to jump to end. This moves 100 to P0, sleep 1. Oh, that's gonna suck. Can I can jump to start, but that doesn't sleep us. We didn't sleep. And we don't have a sleep. And it looks like an ad is gonna start in 2.5 minutes. I'll probably go and grab my breakfast smoothie at that time. I could do a second memory thing and it reads it if we're firing or not. And then that fires or not. And that would save us a little bit of space here. I basically want to sleep and move back and like go back into the beginning. But I don't have something like that. I don't have like a restart. We have just a bunch of these pluses, and then I have this minus, which kind of sucks because I can't like jump to the minus. And just like have it run that, unless they'll let me do that. Wait. This is a minus. If it fails, it goes to the first minus, which is this, and then it restarts. This just might work. Let's find out. Or we just can't fire it all ever again. Cool. what happens here? So we get to, I reload, and okay, we have the 5 data, and now we are pulling the trigger. So we see 10, so it's not reload. So we skip that one. If you're 10, I then also see if you're alive. We are alive. Oh, I need to read. Oh, I need to read it. Okay. I need to keep up with reading it. Oh, okay. So I need to read it every tick too, regardless. Wait, am I not reading that? I thought this would read it. Does reading it mean I need to move it into ACC? All right, ad break time. I'm gonna go grab my breakfast really quickly, and then we'll continue on. So I will be right back. Okay, I think I don't understand how this is working still. So I thought that when I read to it, it auto updates, but I wonder if reading in it, I need to move it. Wait a second. What's going on with this? I move 2 to X3, so I move something into A0. But then I move... Oh. Move 0 to X3. Okay, so I move that into U. And then I move... When I move something into A1, am I telling it, oh, interesting. What if I do something like this? So this is the A. So what if I want to move? So like we'll call it save. I want to move 0 to x3. And then I want to move that to x2. And I think that should store it in that one for all time. And then I need both of these in here. Ooh. Ooh. How am I gonna get that? I don't have any more X's. This is my only other X. So if I go way out here, so you go there, you go here. Okay, so let's say now I want to okay, so I was trying to test equal if x1 is 100. But before I even do that, I need to move 0 to x2 to tell it that I want to look at the first one. Does that work? Yeah, okay, I understand how this works now. It feels like that's a complete use of the RAM, but I got it to work with it, so there we go. Okay, so what's going on with this? You first send, so A0 isn't a read. A0, you send something to A0 to tell it where you're gonna start reading from, and then it auto increments from there. So over here, I tell it, I move 0 to x3. So I move 0 into here on A0. And that tells it I'm going to write into, to set the like the reader or whatever it is, to this one right here. And then I move the data into it. And then I'm only doing that once, right? Then it resets. Over here, I'm telling it to, at the very beginning, move 0 to x2, which comes out here and comes into the A on this side. And so I'm basically saying, hey, on this side, I want to have the pointer at 0. And then I test to see, okay, are you equal to 100 over here? So it then reads the value in. If you're 100, it returns that out. Now it auto increments in, but then of course I'm only reading one value. By the time it resets again, we're back to, hey, read only from input 1. And that's how I'm using it. So I'm literally only ever using this one spot in the RAM, and I'm ignoring everything else. But it works, so I'm happy with that. Which is pretty cool. Joe, it'd be great if you focused on business instead of constantly suggesting distractions. Also, I would destroy you. Okay. Carl then says, just got word from my friend. He's purchased the building for his first I can't bring myself to write it out. Oh, come on, Carl. His first location. Not sure I want to imagine how much of his retirement he's put into it. It's always nice to have a dream, but sometimes there's a reason you shouldn't pursue it, you know? This guy is just like the negative person who always tells you, don't do whatever you want to do. Don't like pursue your dreams. Don't like start a business. Just go work for somebody else and hope that you have enough money at the end of your life. Cool Dad. Product. Color changing vape pen. Great, we're now getting into vape pen creation. Hope you're all sitting down right now because this one is gonna be big. How big, you ask? Well, you might just be talking to the guy who negotiated a deal to make all of the light up color changing vapes that Cool Dad is gonna give away on this year's global tour. Dang, am I right? This is a huge deal for us. Literally millions of these are going to be given away. Looks rather straightforward. We get color values in, then we control some LEDs to get the shade we want. I put a bunch of extra LEDs in the prototyping bin too, since those should be fun to play with. Little tip for you. See the little triangle at the beginning of an XBus data packet? That's when all of those values in the packet are coming in. It's not like it's one per time unit, right? Yeah? Shame that Cool Dad's actual music, if I can even call it that, sounds like 2008 era dubstep crossed with a parliamentary debate. If Parliament were populated entirely by screaming macaws, I have no idea why he's famous. Okay, Carl is just like the negative person. My girlfriend, Xiaomei, is a fan. Some of it is quite danceable. All right, let's, I guess we'll go in and we'll design the vape pen. Oh, wait, is this an LED? This is a multiple color LED? Radio RX is a non-blocking X-bus input connected to a radio receiver. Red, green, and blue are simple outputs connected to an ultra-bright RGB tricolor LED from top to bottom. When a data packet is received over the radio, pulse the LED as specified. Red, green, blue, and then, okay, so pulse duration. So it's a packet. If a data packet is received while a pulse is in progress, interrupt that pulse. Okay. Do I sleep? I think I have to sleep. That's why I can be interrupted. Okay, so I'm curious. If I just throw you in here, if I just say move 100 to P1. And then I move 100 to P1. Wait, is that's the same color, isn't it? Yeah, these are sleeping. These are supposed to be sleeping. Am I supposed to be sending these to each one? Oh, that's what it is. Okay, RGB. I see. So there's 3 LEDs in here. Okay, so when I receive a 0, okay, these are just the packets I'm receiving in. I got it. And pulse duration. Oh, and the duration is 999. That's why I'm interrupting it. And by pulse duration, it's really just how much it's on by. Okay, so I'm actually just passing these through. So I can't use, oh yeah, okay, so you're just wanting something like this. So I'm not sending anything out, I'm only receiving something. So I'm going like that. But then I need to split off, and I have only... I need 3 outputs here, and I only have 1. Now, yeah, because when you're 25, I want that here, and then this thing only turns into like 1s and 0s. So yeah, okay, I'm gonna need like a follow-on to just forward on. So I can need something like that. So if I do this, then we're just gonna move X0 to P1. Like I don't really care. Ooh, but I do need to keep I need to remember what these are. So okay, so memory is gonna come into play here. All right, reset. Oh, why don't you have memory as something in here? Because it feels like this would be really good to have. To like keep in mind what these are. Or is it because like whenever I stop, okay. I guess I want to check to see how this works. So if I do that, we just send you out here. Hi. You wanna hang out again? It's the Zilby hug time. He's doing this like more often. Hey Zilby, you wanna actually fully lay down? Okay, so I'm really curious. If I move X0 to P1. This will reset every time, so then it'll be 50 and 100. What I want to do is I want to sleep. Let's try sleeping 100. Okay, so it did send the 0 multiple times. What if I did... Okay, so I want to sleep 1, move X0 to P1, and now it's gonna send the 50 out. Oh, which is supposed to go to here. I want to sleep 2. Wait, why isn't that working? Sleep. I sent 50 out, right? No. Okay, I got it. This thing, I get all of this in one go right here. Okay, I read through things. That's where they're talking about it comes in all at once without sleeping. Okay, I think I understand. So we're going to I have to test equal. Okay, so if you're equal to 999, then I want to just jump to end, where we're gonna sleep 1, and then we're good to go. Okay, Zilby's done, but Zilby is back. Oh right, that's why we put him up there. It's like the least bothersome place for him to be right now. Okay, so, it's negative 999 too. Okay, so if you're equal to negative 999, jump to end. Otherwise, we are going to read RGB, and I want to send them off, right? And so we have so if I move X0 to P1, it's almost like I want a minus. Oh, wait, no. Okay, so if you're equal to that, jump to end. Otherwise, I want to move X0 to P1. Oh yeah, and I don't need the minus, don't I? Because like jump already just moves out. So then we're gonna move X0 to, sure, we'll do P0. And then we need this thing here. And I could actually just send it out again, depending upon it changes, but we'll see. This one might be the tough one. And then the duration. So I want to move X0 to ACC. Now at the end of this, we're gonna sleep 1, sub 1. And I think at the beginning, at the end of it, okay, so when am I going to, I guess first we'll check to see, test equal if X0 is that. Part not sleeping. Jump to end. Why are you not sleeping? You should sleep 1. You're not sleeping. Because you're looking for a read. Oh. We could use memory for this. That might be used, well, again, like I could use memory and then that way it doesn't block. Or I always have to send out what you are. Like if I don't sleep at all and I just constantly moving you out. Yeah, this, okay, so this needs to sleep. So you're sleeping there. Yeah, so I just send you out. Is it weird that I want to use memory for this? Because otherwise I have to save. Am I using ACC at all for any of these things? I am not. Wait, I am using ACC, but I can use data. So I can use, move that to date. Oh, because if it's even negative 999, I don't want to do that. When it's reset, then I want to move it, I want to change it down to something else. So I want to, I mean, I could just do something like move date to X3. Why are you not sleeping? Move X0 to P1. You're sending all out on this stuff, and then you're sleeping. Do I need to sleep here? Oh, it's blocked on read. There's a sleep read thing. I might want that. Sleep until data is available to read. Okay, so I think that's what I want to do. I think that what I can do is move that. I don't think I need this at all. I think I should say move x0 to x3. Move this line. I want to sleep x. Oh, SLX. Oh, SLX on x0, and then move x0 to p1. Red is 0? Okay, so move x0. Oh, I lost the first one. I lost the first one. So I need to first move x0 to ACC to keep it. And then test if ACC is equal to that. If it is, we jump to the end. Otherwise, we move ACC to P1, but then I can move the other ones like that. The patterns there are a little bit odd. It's like exactly when it's supposed to move, but it's moving by the wrong amount. No, it's not moving on red. That's what the problem is. Oh, it's a counter. It's a counter. So we wait 4, and then it's supposed to drop to 0. And it doesn't. It always waits until it's interrupted. And I'm subbing 1. Okay, so hold on. So 1, 2, 3, 4. Your data is now 0. Which means now you need to turn off. So okay, so I can test equal to test equal dat and 0. If you're equal to 0, I want to now move. I want to send nothing out. So we're going to move 0 to P0. I guess move 0 to P1. Move 0 to P0. Move 0 to x3. I feel like I want to have this out here, don't I? Like there. And then we move to end. Or, okay, now we just don't play anything at all. Okay, what happened? Oh, because that's equal to 0. Because I don't want dat. I want to test to see if ACC is equal to 0. Same problem. We're at negative 99. Oh, I need to use you. I need to use you as, not that. Okay, so I need to move you to dat. Test dat if you're equal to ACC. Okay, so test equal to dat, negative 99. If you're not equal to negative 99, jump to end. Otherwise, move that equals that. Otherwise, this moves to ACC. Okay. Oh, still the same problem. Our ACC is, oh, our ACC is 1. Okay, so off by 1 error. So I want to say test if equal to ACC. If you're 1 now, we reset to 0. If you're, oh, I should probably test less than ACC 2. Wait, why am I getting 999 in there? Where am I moving? Oh no, because it's the 999. Yeah, that does make sense. So when you get to here, 4, 3, 2, 1. Move you to data. It's negative 9999, so that we're still there. If you're equal, oh, if you're equal to that, I jump to end. That's my problem. Okay, so I jump to end, and then before I sleep 1, I need to do this. We're going to test then less than ACC 2. And if we are, we move you. Okay. Off by 1 error. So ACC 1. There we go. Excellent. That wasn't too bad. Greetings all. With every project we take, there are factors we can control and factors we cannot control. We could not control the fact that Cool Dad was arrested and jailed for possession of amphetamines as he attempted to enter Japan, thus canceling the world tour. However, there was something under our control, and that was the terms of the deal. We could have negotiated a better contract and would have allowed us some recourse if something like this happened, instead of leaving us on a hook with 100,000 useless color-changing light-up vapes for us to dump at basement prices just to get rid of them. Great. Good job, good job, sales. Probably should know about working with content creators. I guess he's not a content creator, but he's a musician or something. All right, well, move on from that. This company is not doing very well. I mean, his name is Cool Dad. What did they expect? Yeah, I know. Product: unknown optimization device. Okay. From Poseidon 779 outreach at control.poseidon. Poseidon 779, a decentralized autonomous corporation, has determined that thorium mining operations can be optimized by as much as 2.7% by creating a device with certain specifications. The specifications are included in this communique. Please create 50 of these devices and ship to 101 Jibahao Road. That is way pronounced incorrectly. Sorry. Is that how actual addresses look like in China? That's a lot. Payment will be forwarded upon verification of completed work. No. Are we actually going to accept work that we don't get paid for? This could be another. Okay, so if this company fails, it's just because we're constantly doing work with no pay, for no pay. You guys, cities are so big they have subdivisions. Yeah, I've never sent anything to China, so I have no idea what the addresses like and mailing addresses would look like. What is this? A decentralized autonomous corporation is a company run without human involvement. It has money and investors, but it makes decisions for itself on what to do with that money using information from multiple lower-level monitoring and analysis programs. Some of my classmates were studying them when I was at Princeton, but lately the hype died down somewhat. I guess there are some still operating now, maybe even doing well. Why don't we do the job for it and see what happens? Okay, so let me see if I get this straight. I know I'm a lowly employee here who's just doing this, but I just want to ask some questions. First, I don't care the fact that it's an autonomous corporation, even though that's kind of weird. But an autonomous corporation, so an AI running a corporation, emailed us with an order telling us that they'll pay us when we've completed the work, which costs us money to do. And we're just going to do it without like any questions whatsoever. We deserve to fail. This is like the worst run business I've ever seen. X and Y are simple inputs connected to an unknown device, presumably some type of position sensor. Power is a simple output connected to an unknown device, presumably some type of motor or high power switch. We're gonna break so much stuff. Okay. Map the XY coordinate to the corresponding power value as specified in the Poseidon 779's geometric specifications. Okay. A POS EID. Poseidon 779 thorium mining unit, actuator control subsystem. Okay. Okay, so if X, so X is less than 20. So if X is less than 20, we send out 30. If X is between 20 and 40, we send out 0. Okay, so then we send out, no, otherwise we send out, oh, 30 in here. Okay, this is weird. Okay, so if X is less than 20, we send out 30. If X is between 20 and 40, we send out 0. If X is greater than 40 and less than 80, we send out 30 unless Y is between 40 and 80, in which we send out 50 if it's less than 60. Okay. We get paid. This is a sales project. That's true. That's very true. We're presumably getting paid regardless, right? So like, it just, you know, we spend so much time trying to find this job. It would really suck if they just like failed because they couldn't actually like get paid for anything. That being said, I'm curious. How many of you, or if you're watching this in a VOD, put it in your comments. How many of you have worked at companies that they chose to take work without getting paid for it, and then later on didn't get paid for it? Like the company, not you. Like the company didn't get paid for work that they were doing. Because this has happened to places that I've worked at multiple times. And it has led to very bad things. This is a geometric visualization of a state space. The 2A27 actuator control must take a value as shown in specifications dependent on inputs as described. The zero value area in the middle is required so that the actuator avoids the flux input. Create a device that maps given coordinates to the corresponding power value as specified in this geometric visualization. Okay. So this is gonna be fun. Interesting that they're not recommending everything other than this. So they think that I can just grab states from these two different things. So your P is coming in, right? So I can't use this because I need like actual information. So if I put you in there, you never did electrical engineering contract work, but you imagine the worst part of the job is getting contracts saying this is a proprietary part. You can't know how this works, but here's some awful specs of what you can feed into it. I also would imagine that's pretty common. Okay, so we have this. Now, we can check, okay, so it's really just like state space, right? So if I first move, let's say I just move P1 to ACC. Then let's say this for 31 goes in ACC. So if we just check, so test less than ACC 30, we're gonna move, no, less than 20. We're gonna move 30 out to power, which I don't have that, so I need to just do something silly like this. Okay, so we're gonna move 30 to X3. And you know what? Let's actually just save. Let's move 30 to DAT. At the very end here, we're gonna move DAT to X3, and then that goes out. So if you get past this, and then I probably want to just go to the end. So jump end. Sleep 1. And then we go out again. You have a friend that works on a defense contract. I should ask him how often this happens. I would say most of the time. That'd be interesting. For me, when I was working, it was software stuff. So a company had asked our company to build stuff for them, but they weren't really sure if they wanted to do. So could we deliver some value to show them how we worked and all that stuff, and then they would decide if they wanted to get, you know, to write up a contract afterwards. So without a contract, they had us so there's no intent. There was a verbal intent to pay, but no written intent to pay, or intent to purchase, I think is what it's called. They our company then did that. So this is several companies I worked at previously, and after that they said, oh, this is good, this is great, we're gonna can you also do this thing, and also can we have some users on it to, like, you know, test it out? We still want to test. So we onboarded sales onboarded some users, and it kept on asking for changes. There was no payment. Like, there was never at a time where they actually, like, signed a contract to, like, pay money to us. So they started using it, getting value out of it, asking for changes, which cost the company money because now we're working for them on doing stuff. There's opportunity costs because now we're not doing stuff for paying customers, and then they just never paid us. I think, like, maybe eventually they did pay us, like, a small amount, but nothing compared to, like, how much it cost the company to do everything, which it sucks so much. Okay, so that's this one state here. If they agreed to pay, isn't that a gentleman agreement? Which is, they agreed. So I believe what they had done, because, like, I wasn't there. I didn't hear. I think they said, like, when we feel that it's, like, in a good state, then we'll buy. But, like, nobody ever got them to, like, agree to, like, actually do a real intent to purchase. And they're like, we don't really feel it's, like, that good for us yet. It's like one of those bullshit type things. Okay, so we're now at less than 20, right? So we're less than 20. And now we can check to see if we're less than 40, we send 0. I'm a little bit concerned because I think we're gonna run out of space. So if it's less than 40, I don't think I need this jump end. Oh, we do. Because this one is testing that. I should do it. I should start from the beginning, or at least from the middle point then. Oh, this is gonna be like a logic problem. I remember doing some of these in college. I did take a few of the computer science math classes. Those are so long ago, and I forget, like, there's some good orders to do like some if statements in to reduce the number of if statements we have to do. Okay, ad starts in 4 minutes. And then during this ad break, I'm probably going to take an extended break because I need to, I have a meeting I have to go attend. I don't know how long it's going to be. Hopefully not too long. Hopefully no more than like 10 minutes or so. But that'll be coming up in 3.5 minutes or so. Okay, so if I test less than 40, so if I start with test less than 40 here, we can move 30 to dat, and then if you're less than 20, I just move. So you're gonna be 0 to dat, 30 to dat. And so now we know that it's greater than 40. So I don't have to check that. I have to check I could check to see if you're greater than 79, then it's 30. And we know it's not that, so I again don't have to do a jump. So now I can just test greater than ACC 79. And this is going to be a move 30 to dat. Okay. So now I have this setup, and this setup. So then the Y's. If the Y is greater than 39, so we know the X. Okay, so if there's any more settings of X, it's going to be in this area. So I can check to see if you're, I want this to be, I don't need to check the X anymore. No, I do. If you're less than 60, okay, so this is where it's going to get fun. I need to check the Y. So if the Y is greater than 40, so test greater than P0 and 40. So if you're greater than 40, and then I guess I also want to do test. Oh, how am I going to do this side? The 80. If you're okay, ad break started. Saving me time, meeting time. So I'm gonna go ahead and move update break. Put you back here. I'm gonna update you to say meeting break. All right, so I will be back shortly, hopefully no more than 10 minutes or so, but if they're not ready for the meeting, then obviously I'll be back sooner than that. So with that, I will see you shortly. I hope Zilby stays where he is. Otherwise, this won't be quite as fun. If you have any ideas, put them in chat and I will see it when we get back. Okay, be back shortly. Are you gonna take my chair, Zilby? Bet you're gonna. All right, hey, I'm back. And Zilby did indeed take the seat. Not terribly surprising. All right, Zilby, here you can hang out next to the heater. Oh, and let me mute. Okay, so that's good. We remove the brake. And okay. Let's see if we can figure this out. So that is, oh, it's the Y's. We're on the Y's. And so here we're checking to see, okay, so if we're greater than 40, if we're greater than 40, I also have to then test you know what? We know that we're between here for the X and Y. Let's just set let's just move, let's say 80 to dat. So move 80 to dat. And then we can test less than ACC. Okay, so if you're less than 50, if you're less than 60, then 50. Okay, what's the chance that this works? I feel like there's no chance this works the first try, but we'll see. Yeah, completely wrong right off the get-go. So what are we, okay, so we're turning at 18 and I'm getting power. Okay, so we move 22 in, so X is 22. And so 22 is up here, which means that you should be 0 coming out. Okay, so if you're less than 40, move 0 to dat. If you're less than 20, okay, we don't. Greater than ACC, okay, you're not that. Greater than P040, so you're not. Less than ACC, oh, because you're less than 60. And that moves 50 in, right? Yeah. Because I wonder if I need to do something like, okay, also jump to end. That doesn't jump to end right there. Interesting. Yeah, How do I want to do it? Okay, so now I need to, we need to think about a different way of doing this math in. Okay, so if I don't have the y's in here, and we just have this, is the x's working? Okay, so expected 50 is going to be this one right here. So we fail with the y now. I wonder if I should do two things. Like one that does the x's and figures out what the power output for the x would be. That would be interesting. So, okay, if the x I take the input for the x and they ship it off to two different services, two different things. One if it's lower than 40, no, one if it's outside of the range of 40 to 80, and one if it's inside. What if I do that? What if I do something silly? Like we say, okay, move X to ACC, move P0 to ACC. P0 to ACC, I want to check to see, okay, so if you're greater than 40, then we're gonna have a Y to handle this over here. Okay, so want to check to see if you are greater than or equal to 40. So test greater than ACC 39. And then I also want test less than ACC 80. So if you're equal for both of those, I want to move the X down to here. So move ACC to X1. And if we're done, we're done now, right? So then we're going to jump to end, have end here, where we don't do anything at all. We're just gonna sleep one. Otherwise, we're in our normal state, and I have another thing over here, which I don't have to care about the Y's at all. It's just the X's. So then we're just here. We'll just send you out to here. And we'll just move ACC to X3. We sleep one, we go back to here. This would be the Y case, and this is the X only case. So in the X only case, this should be fairly simple. Power is going to be if X is less than 20, okay, so move x1 to ACC, test less than, if you're less than 20, move 30 to P1. I could jump to end at that point, or we can do the entire thing where we move 30 to dat. No, I think I want to jump. So move 30 to P1, jump to end, and end, we're going to move, we're just going to sleep 1. Okay, so we test less than 40. This is 0. And then over here, test if x is greater than 79. And then that's 30 again. Oh, that's interesting. So really it's 0 at all times. Okay, for this x case, it's 0 if it's, oh, okay. So the x only case, we're gonna move 30 to dat, and then we will set it to be 0 if it's in between here. No, we're gonna move 0 to dat. So then, okay, if you are less than 20, so test less than 20, 30 of that, test greater than 60, 59. Okay, so we get that, and then at the very end here, we just want to move that to P1 and sleep 1. And then we start over again. So that might work for this one. And then the Y case is, okay, so we now know, we know that we're within this period, right? I think so. Yeah, so we know X is between here. Okay, so if X is greater than 60, if X is greater than 59, so we're gonna move, let's say 50 to that. Oh, I'm only checking X here. Okay, so I'm only checking that X is in here, like that. Got it. Okay, so if X is greater than, okay, so if I move, I guess we'll do this one first. So we just say move 50 to dat, test greater than 59. Move 80 to dat. Okay, so there's those two set up now. Then we have to test the y's. So because if it's not out of here, we have to send either 0 or a 30. Oh, that's what it is. Okay, so it's just this with, we have to do this entire thing now. You know what's interesting? This is 0 in here, and it's 30 in here, which is minus 50. So if it's outside of the y range, I just take whatever this is and minus 50. So if I assume that you're here in this 80, no, I don't assume. We set you based upon this. So if the x is, okay, so here we go. We have 50 or 80 in here. So we're starting best than that. Now we test to see, okay, so if you're less than 40, okay, so less than P040. Then we want to, I want to use ACC. So move this to ACC, move this to ACC, sub 50. Test greater than P0. If you're greater than 79, sub 50. And okay, whatever you have back here is done. So then we just move you out. Can I do this? Can I have both of you set up? So move ACC to P1, sleep 1. You're sleeping and you're sleeping and you're trying, oh, okay. That didn't work. Oh, I should probably sleep. I should sleep on for X1. And then I do the things. And I need to do the same thing here. Sleep X0. Part not sleeping, blocked on read. You're trying to read. Oh, do you have to be hit every single time? I thought that would be fine. I could have an end. You can also do that where it's like not doing, I could. so what's going on? So move P0 to ACC. Okay, we get the 22. If you're greater than, okay, so if 22 is greater than 39, it's not. Move ACC to X3. So move it out to here. Oh, and then it's waiting for me to put something in here. Okay, so I need to send something out to you. Interesting. Okay. Ayor, hello. How are you doing today? Is it Ire? But regardless. Is this an assembly game? Yes, this is an assembly game with I guess like it's assembly game with a lot of electrical engineering aspects to it too. If I jump to end, I'm moving ACC to 3. Oh, so if I'm moving you to there, I need to move like -1 to X1. We don't sleep here anymore. We then want to test less than X0, 0, X0, or a test equal to X0, -1. So if you're equal to -1, I want to jump to end and just skip everything. Why is that? Okay, so you are not sleeping. Blocked on right. You're... Yeah, that's... Okay, that's trying to move out of here, and you're sleeping X1. Okay, we got a little bit further. Now, okay, so what happens here? Okay, so X coming in is 45. Oh, 45 is going to be in the Y. Okay, 45, test to see, okay, are you greater than 39? Yes, you are. Are you less than 80? You are. Move ACC to X1. Jump to end. And then we're going to sleep here. Now, you, in the meantime, you've checked that you are not -1. Oh, did we lose that? I think we lost it. Okay, so hold on. So I should first move X0 to dat, maybe? And then check to see if dat is -1. And now we have X is dat. Okay, so part not sleeping. So you're here. Test greater than X0, which we already have. Okay, so anytime we're using X0 now is going to be dat. Now you're not sleeping because, okay, so in the off chance I have to do the same thing here. If we jump to end like this, I need to now move -1 to x3. So we're going to start with move x3, move x1. Okay, so we move x1 to ACC, and we're immediately going to test equal ACC -1. If you're -1, jump to end. Like that. Will there be a stream on Screeps? I've played Screeps in the past, and I've enjoyed it quite a bit. I've also played Screeps Arena on stream in the past. So someday, I have a list of games that is sort of like on the Fun Wednesdays, and both Screeps are on them, but along with several other games too. So the answer is eventually, most likely, yes. But I can't promise like when that would be. It could be a long time. Hey, here. Oh. Okay. Mostly worked. What happened here? So $47 is in the Y. So it's greater than 39. It's less than 80. So we're going to move you down here. And you start going. You're going to test to see if you're equal to -1. You're not. Okay, so move 50 to ACC. Move, okay, check, is dat greater than 59? It is not. Is P0, test less than P0 and 40. This is 86. This is outside. Okay, so test less than that, test greater than P0 59. Sorry, 79. You are, so we're gonna sub 50. So that becomes a 0. Oh, but you should be a 50 here. Okay, so we move 50 into ACC. We check to see, okay, so if dat is greater than 59, the X is 47. Yeah. Hold on, it should be 0, right? And the power is thinking, oh, is 0. Okay, never mind. So we're good to go. Okay, test greater than that, sub 50, that becomes 0, move ACC to P1. Oh, but you're 30 here. Right, okay, so I need to reset whatever you are every single time. So we move, oh, okay, so hold on. That idea was appropriately a terrible one. Oh, you're both P. Okay, I need to do this just for the P, the multiple P's coming in. I guess I don't. I might be able to get away with this. So you, I'm here, you come here, and then you go out here. And I just want to check to see whichever one is coming in goes out. Oh, but can I do that? Overlaid, hello. How are you doing today? It has been a while, yeah. Yeah, things do kind of busy. It's the time of year, right? Things usually sort of like start kicking up around springtime, late winter. So totally understandable. Yes, this is sleep until data is available to read on this specific X bus. But I want one or the other, right? And, oh, we're both sending stuff out. How do I know which one to send? If you send a... If you send a 0, okay, so what if I sleep 1 and then I also move like 0 to dat? Oh, move -1 to dat. So that way, no, you're always sending something into dat to send out. No, wait, I jumped to end. Oh, what are you supposed to do? You don't know this game was an objective? Yeah, so this is called Shenzhen I. We're working, we've outsourced ourselves in this game, and so we've moved to China, Shenzhen specifically. And we are attempting to, well, we're now creating basically, I guess like not IoT devices, but we're creating devices for them, electrical engineering type stuff. So we're writing code. We have inputs and outputs, and we have all these components that you can put onto it, and then we have to write assembly code to make it work. So it's a combination of electrical engineering with traces or wires, and then also the code that we're running to sort of do stuff with. I'm not really worried about like trying to be the fastest, like the fastest running or the lowest power or something else. And so they give us some test cases here. So it's basically test-driven development. And in this specific case, the story is kind of weird. A autonomous company has reached out to us and asked us to create these chips that nobody knows what they do, which is fun. So we have inputs and outputs, and then there's an entire manual that comes with this game. And this is what we're trying to max in here. So we're trying to map like, okay, if X is in this area, we send this out. If no one knows what it does, you might as well do what you want, right? I mean, they know what it's supposed to do, but we don't know what it's supposed to do. Okay, so this is sending the 30 out when I don't want it to. I don't want it to send anything out at all, essentially. I wonder, maybe, wait, can I just have it not do that? Can I have it not send out? I'm moving this to dat P1, but what if... Okay, so I move 0 to dat. Oh, I guess I move, oh, I do move 0 to, I move -1 to here. Okay, so if you're equal to -1, jump to end. I think I want to jump to end here. Before we sleep, I want to test equal to ACC -1. So if we're -1, we're not doing anything. So if it's not -1, I do want to move, I would want to move dat to P1. And then we just sleep 1. So that does that. And then you are going to be the same thing, where test equal, okay, jump to dat to move. I could also, yeah, then we just don't do anything at all. Oh, okay, we're still not doing that. Just imagine going to work and being told to create a web app, but not even the client knows what the web app is supposed to do. Agile methodologies at their best. Exactly. Just write the program in C and copy paste the compiled assembly. Would that be cheating? It would be really hard to do, right? Because we're limited by spots, right? And there's specific function, like features, that the C program won't really know. So like I can't like scroll down. So this is all the lines that I have to write with here, which makes it a lot harder. So would it be cheating? No, but would it make it easier? Probably not either. Also, I mean, even web dev, you do deal with proprietary software where you have zero clue what they're doing in the software. You only know the input and the output. Yeah, that's true. There are times like that. Oh, and I didn't even notice. Ad break started. Sorry about that, everybody. I'll be continuing to work through this though. Okay, so the actual is 30. So I sent out this out. Expected actual, so this is going to be 30 and this is going to be 50, so it's trying to do both of them. Which I'm kind of shocked, surprised, sad. Okay, ACC is -1. I jump to end. Oh, end. Oh, because it's repeating what the last thing was. That's what it was. It's whatever. I keep on forgetting that that's how the hardware works. Is that once we set this to go out, that's how it works. Oh, third-party APIs are a perfect example. Yeah, oh yeah, that's true. Because you don't know how people are going to use them. They have to be made very generically. Okay, so I want to, I can't move, I have to move, can I tell something to move nothing out? I think I can't, like once I, wait, isn't there like a null? Oh, there, okay, not the not. I don't want a no operation. Null is a pseudo register. Reading from the null register produces the value 0. Writing to the null register. Okay, so I can't really do that. I think I have to go back to like using something like this. And I have to send out a -1 or the value. So if you're this way, I almost want to, what am I? I'm moving dat. So move ACC to dat. So that will send -1 or the number out. And then this one, I need to do the same thing. So test equal dat -1. We are moving ACC to P1. So this will be move dat to ACC. I think I can get away with this one again. So let's move the top one here. So we're going to move X0 to ACC. We're going to test equal to ACC -1. If you're -1, then we're going to now move P0 to ACC. Can you add comments to the code by chance? Yes. So here, this the top one here, X only case, and then this Y case, these are both comments. Then the negative is the comments take up the space. So we have the same problem with everything else is I can't scroll this. Like I can only scroll like the component list. So if you use a comment, you now have less room for code. It gets really hard to tell what your own code does after a while. Yes, absolutely. It certainly does. And the very last game we played, TIS 100, that was like, that had a very same problem. Less space for code if you add comments. Yes. Yep. Ouch indeed. I have a note. So I can write notes here. And this is it. This is all the notes that I've got. Also, I can't like put notes out here. If I put a note, I lose space on the board. You're starting to wonder if you can run Doom on that? Probably. If you know how to write Doom in this way. Okay, so that writes that thing, and then at the very end, okay, so test equal to ACC -1. If this one's -1, move this into here. Otherwise, move P0 to null. And then finally at the very end, we're gonna move ACC to P1. And sleep 1. I was hoping that this would send out. Oh, I don't want to only, okay, hold on. Move ACC dat, move dat to X2. This should always happen. Okay, I think we got it. I have the most expensive chip at 18 won. I use the most, like close to the most power. I use a lot of power and I use a lot of lines of code, but whatever, we're good. Task verified complete, payment and route. Okay. Hey, we did get paid. Excellent. Glad we actually got paid. What a future we live in, eh? That was cool. Oh, okay. Joe likes to work for autonomous AI devices, I guess. All right, from Carl. So I was chatting with a mate at the pub, and it comes to light those Sheng microcontrollers we use everywhere have a secret instruction that isn't in any of the documentation. Oh, takes the format of Gen P RIRI, and it conveniently generates a pulse on any simple I/O pin. The signal switches on 100 and then off 0 for however many time units you want using the last two operands. Gen P XY is equivalent to move 100p SLPX, move 0p SLPY. Oh, I think we've seen the gen in one of the things that you were showing, Stacking. And I was looking for documentation on that, and that totally explains it. It's not in the manual. Bloody hell, I could have been using this all along and saved so many instructions. Jay, did you know about this? Yes, actually it is in the documentation. The Chinese version. Just like the at conditional. The what? Seems like many instructions are not translated yet. Putting the at symbol at the beginning of an instruction causes it to execute only once. How have you been initializing code? Oh. Oh, you're on a phone, but I found the hidden information. Yeah. Okay, we found the hidden information. Okay, so we're gonna have to play with Gen. Now, I believe the documentation actually has the Chinese version at the end. Oh, it doesn't. They don't even give us the Chinese. Okay, never mind. Otherwise, I was gonna say, like, if you spoke Chinese or if you read Chinese, that'd be hilarious if it just like you could see that the entire time. Yeah, I asked you. I did ask you about that. And you didn't want to say anything. Okay, well that makes sense. We found out about it now. So okay, we have to remember at for initialization, and then we can start playing with Gen. So is this a port? Sleep amount. Sleep amount? Cool. 3 Kingdoms tokens. Okay, from David. To my fellow expats, have you gone to 3 Kingdoms land yet? I just went to the one in Shenzhen. The recreations of ancient Chinese society, they are extremely fascinating. You even get old metal coins that you have to use to buy things with, as if you were really in the past. I watch the reenactors take my coins and then count them by hand. Isn't that bizarre? I thought they could use coin machines to count the money faster, so I negotiated a deal with them to build some here. Isn't the point that it's supposed to be like pretending to be in the past where like there were none of those things? So like did they have coin counters with electronics in the past? Yeah, okay, literally Carl asked the same thing. Carl, I've already spoken to them about the look. The machine will have a beautiful carved faceplate design with dragons and heavenly mountains and all that stuff. It won't look out of place at all. The machine just has to know when you put in the right coin total, such as the price of one, whatever it is. It rings a bell to let the person behind the counter know to hand you your item. Then it makes change in real physical coins. It's really like bygone times. Okay. Okay. I like how we're making like a device to just remove all brain power from the person standing behind the counter. Like, why even have an attendant there anymore? We might as well just have a vending machine. Okay, token-based payment kiosk. In 1, in 5, and in 12 are simple inputs connected to a mechanism that accepts and detects 1, 5, and 12 tokens. Bell is a simple output connected to a solenoid that rings a small bell when triggered. Out 1 and out 5 are simple outputs connected to a mechanism that dispenses 1 and 5 tokens as change. After a sufficient number of coins have been inserted, the payment kiosk should ring the bell and dispense change as indicated in the verification tab. The cost of the item is set by the operator using a dial that can be read as an XBus input. Okay, so we can have the price. Okay, so as they like put things in, we have to count up how many we get. So we have access to a decent amount of stuff here. Interesting. I wonder how we would use this. Oh, we can use you to then see what's coming in. Great, no, it's gonna be like this. So I want to, at the beginning here, move X1. Let's just move into ACC for right now. And we want to check to see, I probably do want memory here, and we can then just store the coins in memory, but I'll wait until I actually need it. Okay, so this will be this is 110.1 if I remember correctly. 110.1 in this order. So if you're 100, you become 1. Okay, great. So if I test, I would imagine these aren't going to come in at the same exact time. Yeah, the coins aren't coming in at the exact same time, so this is perfect. So we can do test equal to ACC. So if you're 100, let's not move it to ACC. Let's move it to DAT. And we're going to add 1. Test equal to that 10. Add 5. Okay, so we add all those things together. And so now we have what we've Oh, and I want to check to see when it's greater than this. Gade, hello. How are you doing today? Despite his criminal mind, this man is behaving well. His reward is the canoe. This time he can sit on the canoe for up to an hour. I don't get that. Is that an internet meme? I don't get the reference. Okay, so... Oh, he wanted test to see if greater than. So if test greater than ACC, if you're greater than X0, then we're done collecting money. And we don't need to collect any money, and we want to ring the bell. And the bell is... So we're gonna gen P1 was it like 100 for 1, 2, 3, 4, 5? Is that how that works? And then we're gonna sleep one. I probably also need to send the money out that we got. So here, let's we gen that. I also want to move ACC to X3, let's say. I want to reset ACC, so move 0 to ACC. And then we start over again. That did not ring the bell. Okay, so data is 100. So I add 1. Oh, that was in 12. I got it. Okay, so I got it backwards. Oh, so when it's in the other way around, okay, so I've got it the opposites. This is, if it's 1, it's 1. If it's 10, it's 5. And if it's 100, it's 12. Why are we at 0 ACC? Am I... Oh. I only want to do that if we had actually successfully. Okay, good. Except that's... The bell is on forever. Oh. Did I get this backwards? Gen P1 5100. Or 100? Did I miscount? 1, 2, 3, 4. Yeah. Okay. So cool. So that works. And now the bell should be on. Huh. Why did that one not work? Yeah, so I moved 0 to ACC. Shouldn't that... Okay, so hold on. After this bell... Oh, you're not... You didn't reset. That should be reset, waiting for the next money thing. But you didn't. So we come to here. We got to 24. Oh, that's like a loop. Okay. It waits for that. Oh. Wait a second. No. Oh, weird. Okay, so I still don't know how to. How does gen work again? Move 100p. Sleep X. Move 0p. Sleep Y. Oh, I don't need. Nope. Cancel. Delete that one. Zero? Part not sleeping. Move ACC to X3. Blocked on right. So, okay, you're now waiting for this to be read somewhere. But it's sending the 24 out. Okay. I think that works, right? If I don't do this... Okay, the bell part is working now. Excellent. Okay, so we're gonna get the total amount out of here when it hits. So if I take you, let's say we do this. I need to then create the change. So let's move X0 to ACC. And we have 5s and 1s, and that's all it is. So if you're greater than 5, then sub 5 and then send out a pulse to here. So test greater than ACC 5. We want to sub 5, move 100. Oh, it's a pulse. It's a pulse. So I just gen P1 100 0. Which is part of those, okay. Also, we want to then go to the end. Because I then don't also want to check to see if there's ones. So jump to end. We're just going to sleep one. Okay, if we get to this point, we're now going to test greater than 1. ACC is 1. If it is, we're going to sub 1. We're going to gen a P1 100. Sorry, a P0 100 0. And we're going to jump to end. Do I need to jump to end here? Because I think this would work, right? This just goes into it 0. Oh, and I need to sleep until SLX X0. Yeah, no point in jumping to the end when you're already there. Yeah, that's what I was thinking. I was wondering if I needed some other instructions. So I don't think I do, but let's find out. Okay, well, that is not right. Okay, so at this point in time, we're about to send out the bell. Okay, so test that one, dash one, 12. Send that pulse. Move the ACC to X3, which is that one. Okay, so we wait for it. We move it to ACC. Okay, so are you greater than 5? You are greater than 5. Sub 5. Gen 1, P100. Okay, so I want to now send a pulse out to 5. Mackle, hello. How are you doing today? You're right. Oh, yes, you're right. I need to... Yeah, okay, I get it. Oh, why did this? Oh no, okay, so I was waiting for the bell to be finished and then that sleeps. Okay, so yeah, we have two problems. First off, we're waiting for the bell to finish ringing, but it's supposed to be dispensing change while the bell rings. And then the second thing here is that I need to handle the case when there's still ones. So if it's sub 1, we gen P0, I don't want to, it's 1. But then I need to test, okay, so test greater than ACC and 0. So if you still have change left, I want to jump. I want to sleep 1 and jump to continue. And continue is going to have to be here. Like that. Okay. So that's great. Now the bell thing, I can't use the gen for 4 here. So I need... You're doing good. I'm playing Shenzhen I for the first time this weekend, so this stream is perfect intro. Nice. I never played Exopunks. My introduction to the game was I played TAS 100 a long time ago, like a couple levels, and really liked it, and then put it down for some reason and didn't play it again until we played on stream, and we beat all the levels except one. We had really trouble with the sequence order, but eventually we got everything else done, which was really awesome. And Shenzhen I seemed like a good sort of natural progression from there. Okay, so instead of gen P1-4, I should gen P1-1-0. So I want to move P0 to ACC. Test if equal ACC 100. So if you're 100, then I want to gen P1 104. And then sleep 1. That's pretty much what we're doing here. And then, so at this point in time, maybe? Ooh, off by 1 error. So this bell... Oh, I need to wait. I need to wait until P0 has something for me. Oh, you must be an X-Bus pin. Oh. Or we can just sleep. Oh no, because I can't sleep until... Okay, fine. That's too bad. Okay, so everybody move 1 to the right. You can't be that. We're gonna take you. Go like that. You XLS on X0. Move X0 there, and then you go out on U1 like that. And then you're not gonna be P1, you're gonna be X2. Yeah, it is sad that Zachtronics has closed shop. It's super sad. Oh, I can't gen on X pins. Oh, that's too bad. Okay, so I could just move 100 to X2. I move 100 X2. Oh, and it will continue moving at. So if you're not greater than that, I need to move 0 to X2. Okay. Oh, because you're generating this. Well, that sucks. Okay, what happens if I don't do that at all? Yeah, it keeps on having the bell output out. Wait, no, I got this wrong. It's P1 4 0. Okay, we got. That's an odd one. Out ones aren't working. Okay, so 100 is going up there. Bell starts. 24 comes in here. We move 0. Okay, so move the 24 into there. If you're greater than 5, set 5. So really, this gen is probably not great. I just want to move. Oh, because I don't want to sleep. I don't think I want to sleep right now, do I? Because it does something else there. Hold on. So gen P1 100, you send that out. We jump to end. Oh, wait, I didn't continue. I think we want to jump to continue at this point regardless and let it pass here. So do the 5s, then do the 1s, and then continue if it hits. Okay, what happens here? I send a lot of outputs to the 5s. Oh, I'm just sending them, I'm giving them all their money back. I'm giving them all their money back. I need to subtract the price. Oh, oops. Yeah, they're not going to be happy with me. That would not be profitable. Oh, come on. Nobody's going to notice. We'll give them this one, and then we'll go to the park, and we get all of our money back, and then we'll give them the ones, then we'll make another one that doesn't, you know, remove all the profits. Okay, so problem with this. Okay, so now everybody needs to move. Okay, so I need the price in here and in here. So I have two choices. I give myself a little bit of space by putting U in like that. So I wait until you're 0 and I move you to ACC 5. So what if I do the same? What if I do the thing that they taught us? So moving this to X3. If I move you to X3, and then I also move X0 to X3. So it's a data frame. So move X0 to ACC, move X0 to DAT. Now I have no, I want to sub DAT. I could just sub X3, and then we continue from there. Sub X0. Oh, that's an odd. Is that off by 1? That's off by 1. Okay, 24 goes in there. I sub the price, that goes to 8. I'm greater than 5. So sub 5, generate a pulse there. Go to continue. Okay, so it's no longer greater than 5, so now am I greater than ACC1? I am. So I sub 1. Oh, I needed to sleep. I didn't sleep. I needed to sleep. So what if I jump to next? Can I do something like this? I do next, label, but also a plus. Kind of. Out 1. Okay, so I have 3 left. Not that. Sub 1. Generate a pulse. If you're greater than 0, it's... Oh, it does go into the plus. Okay, so it goes into that plus. Then we'll go to continue. Greater than 1. Okay, sub 1. Generate a pulse. Oh, greater than... Okay, so you need to be greater than 0. Ooh. What happened there? I give them a bunch of 1s when it should be 5s. Okay, what's the state that we're in? We have 9 in here. It's time to pay. So okay, they put in a 12. We ring the bell. We move. Okay, so we have 21. And the 16. It's like, because there's 5 left. Okay, so... Oh, so it's the same problem. So if it needs to be greater than 4. I think we got it. What? Oh no. Okay, so on the 3rd set of tests, everything's broken. What happened? Okay, so we have okay, so the price is 14 now. We have 13 in there. It's a 1, so we add 1. It's we are not handling the case where there is no change. This doesn't handle that case. So I'm testing if it's greater than ACC X0 minus 1. Oh shoot. Can I do target equal ACC X0 and if it's not, I will also check to see if it's greater than, and then I'll move to these. Yes, that's what it was. We got it. It is a small start, but like us, whoever has global expansion in mind, as it is said. Thank you so much for the ancient wisdom, David. All right, Tilly has another message for us. Okay, remember when I said I only had one thing to complain about Westerners living here? Well, I have another one, so sorry, but here I go. It's complaining about cheese. That's right, talking nonstop about your precious, precious cheese and how they don't exist here. Definitely not in the quantity, quality, and variety that they do in France or Wisconsin or wherever. Well, it might be hard to wrap your head around the fact that an entire civilization and one of the top culinary traditions in the world was developed entirely without curdled milk solids. But it's true. It happened. Which is not to say I don't like cheese myself. I do. Late at night, you might even find me at the McDonald's on Shenzhen Road eating cheeseburgers like the gluttonous young modern global citizen that I am. I'm just saying there's plenty of good and legitimate food that exists without cheese, and it's not like you're going to die for lack of it. Anyway, when you take a picture and you don't say cheese in China, because why would we say that? You say eggplant. You heard me. Eggplant. Kizi. Say it right and it kind of sounds like cheese. Maybe. Okay. So I guess I feel like Tilly is just using these like sort of like helping us out with Chinese interesting, things as an expatriate to just complain. That's what it feels like. Okay, what is next? Sandwich assembler. From Joe. Yo, dogs, I was out drinking last night and realized, you know what Americans love? Sandwiches, am I right? Americans can't get enough sandwiches. I sketched out a quick design for a patriotic sandwich machine where you put in white bread, bologna, mustard. It could play a song when it finishes. Haha! More details to come later when I'm less hungover. Maybe. Oh, he's hungover for that? That was probably too high energy for hungover. I have a keypad that'll work for this, but it uses normal XBus, which will block until a key is pressed. You will figure it out. Okay, fun. All right, my thermos, which has my remaining tea, the cap fell off or came off on the top of the thermos, like the actual bottle. So now I have to rip that off. There we go. Okay, so we have to, okay, so the thing is we're gonna figure out a blocking. Keypad is an XBus input connected to a keypad. Bread, meat, cheese, and mustard are simple outputs connected to mechanisms that dispense those ingredients. Flag is a simple output connected to a motor that raises and lowers a small American flag when a sandwich is complete. When a value is available from the keypad, read it and dispense a sandwich using the information in the following table and the verification tab. I'm so glad that we're not having to worry about like actually doing anything with the bread. It's probably going to be a giant mess and not work. Okay, so when we have 1, it's sandwich time. 2, hold the cheese. 3, extra mustard. All right, Massey. Yeah, let us know how it goes. Or I guess it's cool. That's not an I. Anyways, yeah, have a lot of fun with it, and let us know how you're enjoying it. Okay, dispense a sandwich with extra mustard. Dispense a sandwich, but don't add cheese. Dispense a sandwich with meat, cheese, and mustard. Okay, so you're an X. What are we getting out of here? Actually, I guess we could just see. Oh, so you're gonna give me 1, 3, 2, 1. An actual number. Okay, so I can't just use this straight from it. Now you're going to be fully 1, so we can use the gen function for these again. So on 1, it's just make a sandwich, right? Meat, cheese, and mustard. Does the order matter? Yes, it does. The order does matter. Bread, meat, cheese, mustard. Okay. And then the flag for a little bit of time. I guess so no matter what, whenever we get an input, I want to send out to bread, which I feel like, because we have so many outputs, we're going to need this. Like that. I might need even another one for one down here. Okay, so just to keep those out of the way, let's say I want bread, which is, this is going to be 100, I think I'm sending out. No, it's this direction. So now it's 1, I think I'm sending out. So move you that, and regardless of this, I want to move 100 to X0. So if I do that, oh, this is what he was talking about, that we have this keypad and that's going to cause us problems. Right, we have to wait. So once we have input, then we do this thing. Oh, and that doesn't turn off, right. Okay, that did turn on 1. So I need to move 100 to A0. Okay, so that then works with, oh, there's another bread at the end. Okay, that's gonna be fun. Okay, then we have to find out based on what you are. So we always move that, and then we have to test. If you're 1, you get everything. So if you're oh, and no matter what, we get meat. There's no vegetarian option. So we're gonna move 110 out, and that gets both. Oh, but that doesn't. Ooh, that kind of. That's gonna do it both at the same time, isn't it? That's not what I want. I move 100. I sleep 1. I move 10 to X0. Sleep 1. Oh, this is where the gen comes in. Gen. Oh, but I can only do that on P ports. I can't gen on X. Okay, move that, sleep 0. Okay, so that gets... Meat is now done. Okay, so then cheese. Okay, so then we have to check to see... We send the cheese if it's... Oh, ad break just started. I didn't even realize it was coming. Sorry about that, everybody. I'll probably keep on working through this one, though. Okay, so we have the choice. Okay, so if it's 1, it adds everything. If it's 2, don't add cheese. Okay, so if you're equal to 2, I don't add the cheese. If it's 3, it's extra mustard. So I can check at this point in time if you're equal to cheese. So test equal ACC 2. I don't add the cheese, so I don't do anything at all. But if you're not that, I want to move 1, X0, sleep 1. And so that would be cheese now. Okay. Mustard. We're going to test equal ACC 3. Wait, so there's no... You have to have mustard. So there's only a no cheese option. Perfect. So if there's extra mustard, we just send 2 out. This will be a gen. So maybe I'll just... do a gen. So we're gonna gen P1 2 0. Okay, so if you're equal to that, you do that one. Otherwise, we're gonna gen P1 1 0. And then we're done. I guess. Oh, after. Oh, then another bread. So then move 100 to X0. And I've run out of room. Okay, what can I do? So we can't, so this should work for everything except the flag. Oh, except the cheese. And it didn't do the second bread. I need another sleep in between these. I feel I need to split this out. I need to move, I need to basically tell it to do something else. Let's see, could I do memory here? I could write into the memory like 1 for bread, 1 for meat, a 1 or 0 for cheese, a 2 for the mustard, or a 1 for the mustard. It's like the count. I can put the counts in, like how long these are going to be. So like 0, 1, or 2. And then another bread, and then the flag. We could do that. That might work. Would it save any space here? I'm a little bit worried about that. So yeah, let's keep that around and start over again. So I wouldn't be doing any of this. I probably still need you, but let's just reset. Let's say run it. Wait for x0. And as soon as we have that, let's move you into data. So we store you there. Now we know we need, well, okay, we're also going to move a 0 to x3 because we're starting to write with memory. So we know we need bread, and so we want 1 to bread. So we're going to move 1 to x2. Move 1 to x2. So that's the cheese. That's the meat. Okay, cheese. This is dependent, right? So if it's test equal dat and 2. So if it's yes, we're going to move 0 to x2. Otherwise, we're going to move 1 to x2. And then mustard, test equal to dat 3. If it's true, we're going to move 2 to x2. Otherwise, move 1 to x2. And then finally, the last one, bread. So move 1 to x2. And then we restart over again. You're just going to be really upset at me, aren't you? Fine. Whatever. Okay, so after all this, we have bread, meat, cheese, mustard, bread. Okay, that looks fine. And then after this one, we have bread, meat, cheese, mustard, bread. Okay. And then we have bread, meat, cheese, mustard, bread. Okay, I think this is working. So once you're done with this, we need to tell the next thing to read, which is going to have to be an export here. Yeah, let's just do that. So that's so x1. So we'll sleep until we're told to start going. You're both x's, so I need you go like that. I guess I could go in on the x0. That would probably make more sense. But whatever. The bridges are nice, right? So when we're done, we're gonna move 0 to A to x2. Say, hey, start reading from there. And then we're gonna read one in, and it's gonna be, okay, so bread. So if I move x0 to, let's say, data, so store that in here. No, we're gonna use this as a pulse. Ooh, can I just do this? Can I just say gen on I can't gen on exports. That'd be so much better. So bread that would be so awesome. Okay, so we're gonna move exo. So we know, let's see, bread first. So we're gonna move. I can't multiply by 100. Maybe I could just do that here. So, okay, we're gonna move. What if I just put 100? So if I do that, and I save some space by we're just gonna move x0 to x3. I'm making like sort of a, it's not really functional programming here because you're now assuming what this is gonna do. So if I send you out, oh, this is all gonna do, okay, so this is 100 for that. Oh, and then you're done. And then you're just done. Oh, nothing works. Oh, wait, did I send anything to it? I never sent. You're done, so we're just gonna move. Like move 100 to X1. Yay, infinite loop. I need to sleep. Oh, part not sleeping. Wait, do I have to sleep between all of these? Walk down right, wait. Oh wait, I didn't have to do that before, right? Yeah, because if I don't have you, and I don't have you. Yeah, okay, so I don't need to sleep for writing into memory. I need to sleep. Okay, so checking roll. Move. I do need to send a message out when we're done. Okay, so I need to send a message out when we're done. And so when I do that, it needs to sleep, right? For that thing to get it. Unless I send to one of these things, which we could do. Because I could do something like this. Wait, I could do more than that. Okay, hold on. So let's say, okay, I want to send a message out to say, hey, start reading. What if I go down? Oh, you're a P. Okay, so let's say we do this. I don't need the jumper at all now. Oh, but I can't wait on this, but maybe it's gonna be fine. Maybe no matter what I send something. I think that's what we're gonna have to do. No matter what, we have to send something, and it's either gonna be a -1 or a... So we're just gonna move 100 to P0. And then we sleep. That's gonna not... Oh, I just gen 1 pulse to here. So gen P0, 1, 0. Oh, can I do no sleeps? Could I just say that? I wonder if that would work. I don't think that makes any sense. I don't know if I need this sleep anymore. I might not need to. Okay, so then we're gonna wait. So we're gonna move P0 to ACC. Actually, I don't really care about it, right? That's why it would be an X, because I can wait, I can sleep for it. And just wait for it to send me something, and otherwise I don't do anything at all. I kind of like that. What we had. And that makes the most sense. Okay, so if I just move that to ACC. Oh, I think I have to, I have to sleep between each of these. We have to sleep one, sleep one. And this won't work because I can't generate that out, so I have to move. You're moving on, okay, you're waiting on you. I'm already on this sleep. I don't think that works. Yeah, now it's not sleeping, even though I want it to start sleeping up here. I want it to go back and sleep. But if I, okay, so if I think about this, we can say like we always need bread and meat. We need 2 slices of bread, we always need meat. So it's really just cheese and mustard. So what if we rewrite this to be a little bit simpler? And we say, okay, move U to DAT. And move 0 to X3 to start at 0. And then we're going to only move the cheese and the mustard in. So test equal DAT is 2. So if you're 2, I want to move 0 to X2. Otherwise move 1 to X2. Test equal that 3. Move 2 to X2. 1 X2. And then when we're ready, we're going to move okay, so we're going to move 100 to X1, going to sleep 1, wait for it to read and do its things, and then we go about it. Part not sleeping. I mean, so I wonder if I want something like this, where I don't, then it's like the equivalent to the P0 again. So then I can say, all right, move X2 to DAT, let's say, or ACC. I want to check to see. Okay, test if equal to 0. If it is, we're going to jump to end. Okay, so if ACC is equal to 0, we jump to end. Otherwise, we're going to continue on. So we're on 100. It's time to make the sandwich. So this could now be a gen. Gen P0, 1, 0. Okay, so move view to ACC. Test if it's equal to 0, we go to end. If it's not equal to 0, we want to send a bread out, right? Oh, that's an X. Okay, so we send a bread out, so we're going to move. We want a gen. I can't do gen. 100. X3. Cheese. Okay, so then oh, and there's one or that, so I could actually just send that. So move X0 to X3. Then muster time. So on a gen on P1 for X number, so that's going to be X0 0 number times. And then the flag. So, okay, I'll kind of want to see what happens if we flag and sleep 1. If we do this, is everything working other than a flag? We're off by 1 at every single one. Oh, I'm already here. Well, that's why the sleep is necessary. Do I want to put the sleep at the beginning? But what if I have a start set and we sleep 1? We just dump to start. Oh, we're still off by 1. Ooh, what if I do the... sleep one, and then we sleep another one. Well, that didn't work. I didn't move. I don't think this gen is helping me. Maybe it is. I'm not sending anything else until then. I want to move P0 to here, so I'm waiting until this has something in it. Oh, I don't need to sleep one down there. I just need to... Ooh, what if I do this? Oh, we're missing everything. Nothing works. Cool. Infinite loop. I feel like the SLX is the way to go here. Like, I feel that's what I really want to do. I feel like I just want this. I'd have to go do the entire thing where I come around it again. So if I do that, okay, so we SLX X2. Move X2 to ACC. Okay, so if you're 0, I don't have to do this anymore. Send that out, send that out, send that out, sleep, gen. Oh, but I can't gen. We have to move. I don't actually care about what's in there. Okay, so you're moving out on X1. Okay, so you move 100 out there. Oh, do I want to do something like this? Move 100, move 0. And then I want to move both of them down. So I move X2 to null, move X2 to null. Or I just move one of them and I don't have a second one. Okay, better. We're actually running now. Okay, so the first sandwich, cheese, went on forever. So let's see, we have bread, cheese. So move that to sleep one. Wait, why did you send out forever? Okay, you send out. cheese is still active. Oh, because I have to reset it afterwards. So after all this is done, move 0 to x3. Okay, and then we need another bread. So move. Okay, so then 100 x3. That gets the final bread. That doesn't get the final bread. So, because I need to sleep one. Wait, why am I off by 1 there? Now, why did that happen? Oh, this. Oh, the mustard's separate. Oh, yeah, okay. That makes it actually a little bit harder. Because I'm sending, okay, so send out bread, send out meat, send out cheese, or not. Sleep after each of those, and then send another, oh, I don't want to send out another bread. Then I send out mustard. Then I send out bread again. Sleep 1. Then move 0, x3, sleep 1. Oh, we gave 2 cheeses. We got, okay, so we got things at the wrong times. Oh, I bet this Gen P1 doesn't really work the way we expect it to. Which kind of sucks. I was really hoping that it would do... I was really hoping that would do that. Actually, no, it does exactly what we want to do for... Okay, it does what it had there. Okay, so the cheese one. So we have bread, bread, meat, cheese, send you out. So move X out to X3, sleep 1. Because you're storing 1 for the cheese. That should be 1. Okay, so I sent out 1, sleep 1, gen that. Oh, I forget, we have to reset now. Okay, so gen 1, so before that, we have to also now move 0 to x3, and then we gen that. Okay, so that's good for all those. The flag's not raising, and you're not being set properly. So what's going on with this? This cheese doesn't raise. Okay, so move you out. I moved 0 out when I did want the cheese. Oh, I didn't reset where we're reading from. Oh, no, that's a problem. Oh, yeah. Now I don't have room here. Okay, so I didn't make this work. At some point in time, I need to initialize to set my read with x1 to 0 at the beginning of every loop. Now, do I need this sleep? If not, then what we can do is we can just say move 0 to x1. Okay, a lot better. A lot better on this. We become off by 1 with this mustard. So we're not doing cheese. So here's our lack of cheese. So move that to here. Oh, but then I'm sleeping. And I don't want to sleep. Can I get rid of this sleep? No, because we don't want it. Okay, so sometimes we need it to sleep and sometimes we don't. Oh, but maybe I can sleep. Oh, this is gonna suck. This sucks. Okay, I don't think the memory is working for us. Maybe we should just do a data frame and like just send all the stuff in the data frame. Okay, I want to experiment with a new design. So, thought on this. Let's say we take you in and also, okay, so we're going to take you in and I want to just use a data frame out to the next thing to send out all the messages for everything. So we just figure out what this is. So we sleep until x1 has something in it. We're going to move x1 to, let's say, date. We're going to check to see, okay, so no matter what, we're going to do okay, so I think it's 100, so we're going to move 100 to x3. We're going to move 10 to x3. Then it's going to be cheese. So then we're going to test equal to dat if it's 2. So if it's 2, we're going to move 0 to x3. Otherwise, we're going to move 1 to x3. We're going to test equal to dat 3. Move 2 to x3. Move 1 to x3. And that's everything out. And then we just repeat this over and over again. Right, so you're just waiting for these things to happen now. Okay, so if we take that, and now we're gonna capture you in here. And so we're gonna SLX next one. Okay, so as soon as we have you, I guess like each way through, we're gonna get something, right? I don't think I have to sleep. I think we can just go straight into like move this in. So the first one is, oh, and then forgot at the end. So that then we have to move 100 to x3. And then I guess we could sleep one. Then we're done. Okay, so we're gonna move. We're gonna get bread first. Okay, so we do this thing. So we start by moving x1 to x3. Sleep 1, move x1 to x3. Cheese, the same thing. Move x1 to x3. Except when it's not cheese. So this one we have to move you to, let's say dat. Move you to dat. We're going to test equal. Dat is 0. So if you're 0, if you're not 0, we're going to move dat to x3. And we're going to sleep 1. Otherwise, we're now going to move the mustard out. So now we're going to gen a pulse for the mustard. So gen p0 x1 0 for the mustard. And then finally, move 100. Oh, we just moved x1 to x3 again. Move 0, sleep 1. Move 0 to x3, sleep 1. Does this do everything about the flag? I do have to wait. Okay, so SLX X1. Oh, because I have these move. Oh, okay. I was hoping that would work, that I could sleep here but not sleep here and then get that, but that doesn't work at all. So it does feel like the stack of memory actually is a good idea. Yeah, my brain is starting to fry a little bit, so it's a little bit hard for me to like think anymore, think creatively. So, I'm trying to use those as like a data frame. I don't want to actually sleep, but you need to be sent out. I wonder if I want to use something like a memory after this one, where then I send like the memory that goes into here. I don't know what I'm getting. Like, I'm just like moving things around. Yeah, I don't know. I feel like there's a way better solution to do this, but I don't think it's a good idea for me to try to continue on for too much longer, because I think I'm in that sort of like state where I'm sort of like hyper focusing on one solution at a time, as opposed to like letting myself like come up with the creative one. So I'm thinking that this is probably a good time for me to take a break. And by break, I mean end the stream. And which is also probably a good idea, because I need to go out and do some grocery shopping today. And apparently there's a mega storm coming in that's going to dump a bunch of snow on us, which is not great. And it's also like getting pretty late in the year for us to like have that. But oh well. So I think what we're going to do is we're going to call it a day. We're going to come back to this next time and figure it out. I think that's what we're going to do. All right, so everybody, thank you so much for hanging out with me today. Zilby, after he left his spot, just hung out on the chair the entire time, sleeping next to the heater. So unfortunately, you didn't get to see too much of that, but we made some good progress until we got to this point, and I sort of just ran into a wall. But I should be good to go for next week, and hopefully we'll figure this one out. And with that, I don't think I have anything else. So I'll be back on Monday for more LMS web development. So with that, have a great rest of your day, and I will see you next time. Bye.